Right. So let us come back to the first topic of your chapter. Last video we have seen the introduction, what is there given in your NCERT textbook, right? So first of all, before going into the chapter, first I need to know what is a chemical reaction. So if somebody asks me what is a chemical reaction, right? So I'm writing reaction as RXN. So if I have to know the definition of this, nothing simple, students. See, everything in this nature gets converted. Means if I have to speak, suppose to form this pen, you need some sort of raw materials to combine. Those raw materials combine together at certain temperature and finally form this. And they mold this. So what does it mean? There is a transformation or conversion of one react or one substance into a new substance. Okay, indirectly. Chemical reaction is a process. Let us write. It is a process. It is a process in which, what is there in that? In which new substances are formed. Okay, right? This is what happens, isn't it? Two different substances have mixed up, or two or more substances have mixed up, and a new substance is formed from this. So this new substance is formed with different properties different from their, if I have to say parent atoms, let me say parent atoms. Okay, so different properties in the parent atom. That means whatever has initially combined together, the properties of those will be different when compared to the products. That means if there's a reactant combining A plus B. So there are two substances here. One is substance A, one is substance B. Both are combining and giving me a new product, that is C plus D. That means the C plus D, whatever is formed, that is a new substance which is formed, and the properties of this will be different from the properties of this. That is what you need to remember. So here the properties of the compound formed is different from the properties of the parent atom. So these two are called the parent atoms, and this is a new compound formed. This is what is a chemical reaction. Now when I have to speak about chemical reactions which are happening, there are enormous chemical reactions which are happening in and around. Let us take some examples. Suppose let us start from your house. Here in your house, the basic example is souring of curd. When the curd is kept outside, it will become sour. More number of hours, it will become sour, isn't it? Isn't it not a chemical reaction? Settling of milk into curd, that is also a chemical reaction. Digestion of food is a chemical reaction. Respiration is a chemical reaction. Photosynthesis is a chemical reaction. Oxidation or rusting of iron is a chemical reaction. Lot. You know, if I have to speak everything, burning, wax is burning, physical change, that's a chemical reaction. There's evolution of water and gas also. And then if you have to speak your oxidation of foods, when you keep your food outside, it gets rancid. Like that, everything here has a amount of chemical reaction. So in this chapter, we'll be studying these chemical reactions, how actually are, means how are they characterized, how should you remember, what are the characteristics of this. So now as a concept, I know chemical reaction. If somebody asks me, chemical reaction means formation of new substances. Point number one. If they ask me formation of new substance, what is important thing? They will have a property different from the parent atom. Done. If they ask you examples, just now I have listed a lot of examples. Okay, some more examples shall we do? Okay, your inverter battery reaction, that is also a chemical reaction. Simple, isn't it? Suppose if you take your refrigerator, freons are released. That is also a chemical reaction which is happening. So everywhere, like, you know, if you speak list of chemical reactions, you can add that. Burning of fossil fuels, it is there. Burning of wood, coal, carbon, all these, right? So now let us come and see the important thing, that is characteristics of chemical reactions. Let us erase this. So when I have to speak, or somebody asks me what are the characteristics, how can you say it is a chemical reaction has happened? Then you can say the chemistry, characteristics are something which will explain, okay, this reaction has happened, a precipitate has formed. This reaction has happened, a gas is evolved. This reaction has happened, change in temperature. Let us write that. Now we are going to learn a topic, that is characteristics of chemical reactions. Characteristics of chemical reactions. So, ma'am, why should I learn this characteristics of chemical reaction? Suppose, let us take one general example. Suppose your name is some XYZ. So when somebody asks me, do you know that boy or do you know that girl? Somebody, just if they ask you which girl, okay, that girl who is tall, that boy who is smart, or that boy who is fair enough, or that boy who is like fat in anything. So that particular characteristic, or the boy who speaks fast, the boy who is good in running, like that, different characteristics characterize your personality. In the same way, even for a chemical reaction, if I have to say, what are the different characteristics? First thing, whenever a chemical reaction occurs, or whenever you have a formation of reactants to products, different things may happen. That is, there may be evolution of light and heat, or evolution. Sometimes the light may be evolved, something like magnesium ribbon. Heat may be evolved, just something like iron. You do your thermic reaction, isn't it? In that way, where heat is generated, that heat is used to mold the railway tracks. Next would be, after evolution of light, there can be formation of precipitates. So precipitates, what are precipitates? Basically, simple example. See, in your lab, when you are adding two substances, okay, one test tube you have one substance, one more test tube you have one more. When you add, after mixing also, there is a thick solid which is formed at the base of the test tube, the insoluble product. So precipitate is nothing but insoluble substance. So there may be reactions where formation of precipitate is observed. There are certain reactions where there is change in temperature. So temperature may be changed, where the beaker or the test tube may become very cold. The beaker or test tube may become very hot also. So there are two varieties of reactions, that is endothermic reactions, that means where endo means absorption, taking thermal means heat. So heat can be absorbed, then the beaker or the test tube will become cold. There are certain reactions like exothermic reactions, where exo means out, giving out. Thermic means heat, giving out heat. So there are certain reactions where endothermic heat will be absorbed, exothermic heat will be evolved. So such type of reactions also this or that may happen in certain reactions, right? I can give the characteristic of reaction where we have seen formation of PPT done, evolution of light or heat we have done, light, heat or gas, vapors. If I can say gas or vapors also, this also I can write, right? And next important thing, here certain reactions are there where PPT is there, temperature is there, light, heat is there, they may be change in color. So most of the reactions we see change in color also, change in color. So means different colors, colorless to yellow, precipitate, orange, loads. I'll be explaining a lot of examples where important thing in your MCQs or your answers, they'll be asking you the color change. So you should be very clear about that. So here now I have understood what is chemical reaction definition. Then I have listed out a lot of examples. Then I have learned a topic called characteristics of chemical reactions. I said I can just say a chemical reaction has happened when certain things occur or certain things will be observed in those reactions, right? So now little understanding I came into the topic. Now next you're going to watch important thing, one example for one. I'll be taking one example and explaining you in detail what are the characteristics of a chemical equation or chemical reaction. So let's meet in the next video with characteristics of chemical reactions. Right, students, now let us come back and do the first characteristic of your chemical reactions, that is evolution of gas. So for every concept, let us take two examples and understand. Right, so here in this video we will write the heading as detailed explanation of characteristics of chemical reactions. Okay, right. So this is a detailed explanation. Let us take an example. So what characteristic we said? We said evolution of gas, light, heat, change of temperature, change of color, and formation of precipitate. I'll be taking the first example, that is evolution of gas. So let us take two examples for this. Here, simple. So we have studied. Normally, whenever I take a small metal, let us take zinc metal, magnesium metal, aluminium metal, sodium metal, highly reactive metals rather. Suppose if I take a beaker like this, okay. So I'm taking a beaker. In that, what am I going to do? I'm going to drop in few zinc pieces of zinc metal in this zinc metal. So I'm going to take zinc. Zn is zinc. Then what is the physical state of zinc? It's nothing but solid. To this, what am I going to do? I'm going to add an acid, that is dilute HCl, or you can also add dilute sulfuric acid. So an acid will be added to this dilute HCl. So let me take as HCl here. So here the HCl is in the liquid state. Done. So here what am I going to do? When this reaction happens, after some time you're going to cork it like this. Cork means you're going to seal it and you're going to observe it. What are you going to see? Zinc reacts with chlorine and it forms zinc chloride, that is a salt. Along with this is a solid. Along with this, there is an evolution of hydrogen gas. So hydrogen gas is evolved from here. So this hydrogen gas, how can I test hydrogen gas? So whatever hydrogen gas is evolved from here, when I put a burning candle or a burning splinter, so you take one candle and put it under this, it will start popping. Hydrogen gas, what is its characteristics? It has a pop sound. It will burn just like a popcorn, pop, pop, pop. It's going to pop, give us a pop sound. So hydrogen gas is tested by which one? Pop sound. So what is a pop sound? So what does it say? Whenever a metal reacts with an acid, let it be HCl, sulfuric acid, there is an evolution of a hydrogen gas. Metal plus acid gives hydrogen gas. So isn't it an evolution of gas? Yes, simple. One more example we'll take. So with this, what can I say? Because there is evolution of gas in this reaction, I can say that there is a certain amount of particular chemical reaction has occurred. Why did I justify like that? I said whenever a chemical reaction has or occurred, if you have to justify, you can say that if there is evolution of gas, light or heat, I can justify that is a chemical reaction has happened. If there is formation of PPT, chemical reaction has occurred. Change in color, chemical reaction has occurred. Change in temperature, chemical reaction has occurred. So I have taken the first characteristic here, proving that evolution of hydrogen gas, which is tested by a candle by pop sound. Simple. Now let me again take one more. I'm going to take HCl. So what am I going to do? I'm going to take a beaker again like this. In this beaker, I'm going to add Na2CO3 for sodium carbonate. So I'm going to take sodium carbonate, which is in the solid form. To this I'm going to add HCl, dilute HCl. So when these two combine, remember there is carbonate here. The first thing here important, carbonate, it comes out in the form of carbon dioxide gas. So carbon dioxide gas comes out. Okay, I need to collect it. So I'll just keep it for a while like this. Along with this, you will also be getting water in this. Along with this, a salt, that is NaCl, is formed. So what is happening during this process? You are taking sodium carbonate, you are adding carbon dioxide and HCl. Now because carbon dioxide is a colorless gas, how can I test it? I am going to take the same beaker. I have drawn it little bit down, not so neat, but just for your understanding. So here during this process, what water formed? Sodium chloride is formed here at the base. Then water drops are formed here. Carbon dioxide gas, I am going to collect it through a delivery tube like this. And I am going to introduce this carbon dioxide gas into what? Into a test tube containing lime water. So I am going to take lime water. What is lime water formula? Lime water is nothing but calcium hydroxide. So I am going to take lime water, calcium hydroxide here. So when this carbon dioxide gas is passed into this test tube containing lime water, immediately, first of all, lime water color is what? Lime water color is colorless. So when you add carbon dioxide to lime water, immediately this becomes milky, or it turns milky. So lime water turns milky. What is this reaction? We'll see that also. First thing, I have taken an acid and I added to sodium carbonate. I've added sodium carbonate was there. To that I have added acid. Then I got sodium chloride here. This is sodium chloride, water, droplets, and carbon dioxide, whatever is evolved. I have taken that and I have allowed it through a delivery tube. I've allowed it to enter into lime water. So lime water, how did I prove carbon dioxide gas is evolved? Because lime water has turned milky. It proved that carbon dioxide gas is evolved. So what is the reaction? So carbon dioxide plus lime water gives me calcium carbonate. Calcium carbonate, right? So as usual, calcium carbonate is a white PPT, or it turns lime water milky, you know. So this is milky white. So what is the conclusion of this? It says that whenever there is an evolution of gas, which I tested with the pop sound using a burning candle, whenever there is an evolution of gas like this in this reaction, which I tested with lime water in this way, I can say that the particular chemical reaction, there is evolution of gas. That means certain amount of reactants are getting converted into the products. So that is the first characteristic of your chemical reaction. Now let us come and see the next characteristic, that is formation of precipitates. Right. So the next characteristics of a chemical reaction is formation of precipitate. So basically what actually is a precipitate? Let's define in three different ways. So if I have to speak about precipitate, precipitate is nothing but an insoluble substance. Okay, now insoluble substance, when it is formed here, this insoluble substance can be formed when you're mixing an aqueous solution. Aqueous solution means a particular solution which is dissolved in water, a substance which is dissolved in water, aqueous solution into one more aqueous solution, if you dissolve both of them. So these two, if they are, means one is not soluble in other. That means one aqueous solution with water is not soluble, it will form two different layers. So aqueous solution is dissolved into one more aqueous solution which is insoluble. So here, because of this also we call it as precipitate. Means if this is a test tube like this, here one aqueous solution will be there, one more aqueous solution will be there. Let me take a red pen. So one more aqueous solution will be there. So then also I call it as a precipitate. Next important thing, when you are dissolving a gas, a gas over aqueous solution. So when you're dissolving a gas over aqueous solution also, then also you get a precipitate. Next, suppose if you're dissolving two different colorless solutions together, when there is exchange of ions, also precipitate forms. So let us write, when there is exchange of ions, also precipitate forms. So basically these are the different circumstances or situations where you find precipitate. Either aqueous solution to aqueous solution, if they are immiscible, it will form two separate layers, then also we call precipitate. When you are taking or dissolving, you are sending a gas into an aqueous solution, that also doesn't dissolve, then also I call it as an aqueous precipitate. Suppose there is exchange of ions like double displacement reaction, there also you call it as or you find the formation of precipitate. Now let us take an example and see. So here in formation of precipitates, the classic example which you have is lead, or let us say, first I'll take potassium iodide. So next I take lead nitrate, PbNO3, right? So here PbNO3 taken twice. This is one reaction. What is the important thing you need to remember? Here potassium iodide which you are taking is colorless in nature, aqueous solution. Lead nitrate which you are taking is also colorless in nature. Both are colorless. When you are mixing these two together, you are going to get an exchange of ion and forms a compound, that is, one is PbI2 and one more is KNO3. Now, what is the color of this? PbI2 combines, or this together exchange of ions, there's a formation of an yellow color precipitate, yellow color. I'll be showing to you in the activity. There is an activity which is attached to the end of the video. You can see the beautiful yellow color of lead iodide. So here what is happening, from colorless to an yellow precipitate, a thick precipitate will be formed at the base, indicating that the chemical reaction has occurred. Let us take one more. Suppose if I take barium chloride and sodium sulfate. Here also same thing. There is exchange of ions. What do you get? You get barium sulfate, a white color PPT, barium sulfate, sodium chloride. So white color PPT is formed at the base of the test tube, and along with that sodium chloride. Here what is happening? First of all, it was your barium chloride which was colorless, sodium sulfate also same thing. When they combine together, it's forming a white PPT. So what is this yellow PPT, white PPT indicating? This formation of yellow PPT or the formation of white PPT indicates that a chemical reaction has occurred in that particular test tube or a beaker. So isn't it characteristic of a chemical reaction? In the earlier example, we have seen an evolution of gas. Next in this, we have seen the formation of precipitate. Now let's come back and see the next characteristic of a chemical reaction. Right, now let us come back and see the third characteristic of a chemical reaction, that is change in color. So when there are certain chemical reactions where you find the complete change in color from colorless to some other color or some other color to colorless. Let us take an example. So here the important example which they ask you for your grade 10, that is, I'm going to take two examples. Both are very important for you. Please note it. Here suppose if I'm having a test tube. Okay, here to this test tube I'm going to add potassium dichromate, K2Cr2O7. For you, nothing to remember with the formula because you're just entered into this chemistry subject. So remember the color. So potassium dichromate, the color of these crystal, it is a solid crystal. So these are crystals. The color of this is nothing but orange. Right. So when you add potassium dichromate to this, an orange color crystal. Now what you're going to do, you are going to add sulfur dioxide to this. So when you add sulfur dioxide, immediately there is change of color from orange. The potassium dichromate crystals, whatever are there, they are going to change into green color. So isn't it change in color? So what should you remember? You need to remember the one of the characteristic of chemical reaction, just like when potassium dichromate, the orange color crystals are taken. When sulfur dioxide gas is passed to it, immediately the orange color crystals are getting converted into green color crystals. Remember that. So isn't it change of color? Let us take one more example. Suppose this is a classic example, very important for you NCERT also. Right. In a test tube, I'm going to take potassium permanganate. So potassium permanganate, you will see this in the activity also. So the potassium permanganate color is purple in color. So here to this purple color potassium permanganate, I'm going to add citric acid. What am I going to add? Citric acid. So you're going to add to this citric acid. Don't get confused, students. Nothing. If you just citric acid formula, dichromate formula, not required. Remember the colors. So when potassium permanganate, an oxidizing agent, when you take it, the color of potassium permanganate is purple. When I'm adding citric acid to this, immediately this gets converted into a colorless KMnO4. So the purple color, whatever you are having, this whole potassium permanganate, from purple, the potassium permanganate becomes colorless. So what are you observing? Potassium dichromate, let me write it down here. So K2Cr2O7, from which one to which one it has turned? It has turned from orange to green. Okay, right. Potassium permanganate, KMnO4, KMnO4, which color to which color it has changed? It has changed from purple to colorless. So when you are adding citric acid to this, when you are adding sulfur dioxide to this, shall I write that also down? So let us write that also. Potassium dichromate, on adding sulfur dioxide to this, potassium permanganate on adding citric acid to this. So interesting, isn't it, students? So remember, they'll give you in the exam options, what is the color change observed when potassium permanganate is treated with citric acid. So you should be very careful in answering. You should say purple to colorless. Now let's come back and see next characteristic of a chemical reaction. Right. Now let us come and see the next characteristic, that is change in temperature. So earlier in the video I have told you, basically there are two varieties of reactions which are happening. One is exothermic reaction and endothermic reaction. First let us write the temperature change can be in which form? First can be exothermic reactions, and the next type of reaction change would be endothermic reactions. Thermic reactions. So yes, so exo as the name suggests, as I've told, exo means out, giving out. Thermic means heat. So heat is given out. Endo means absorption in. So in opposite to out is in, absorbing inside. Thermic means heat. Right. So heat is absorbed, so heat is given out. When heat is given out, the beaker, whatever you're there, it will become very, very hot. Means when you touch, you will feel that hotness in the beaker. Suppose if heat is absorbed inside, the beaker will become cold. Now let us take an example. Here, nothing. You're going to take a beaker, right? You are going to add calcium oxide. So I'm going to take a beaker, right? To this I'm going to add calcium oxide. So calcium oxide, what is the other name? It is nothing but quicklime, isn't it? Calcium oxide is quicklime. To this you are going to add water, H2O. So you're going to add water. So can I write water as H and OH? Same, isn't it? So just see, calcium combines with OH. 2 OH, 1 OH here, 1 OH here, it becomes calcium hydroxide. What is the other name given for calcium hydroxide? It is nothing but lime water. Okay, here in the conversion of quicklime to lime water, remember after this is over, you stir it completely with a stirrer, when you stir it, and when you touch this beaker, I'm holding this beaker like this, if I touch that, you will feel the beaker becomes very hot. What is happening during this reaction? There is amount of energy, heat evolved. Delta means heat. Heat is evolved in the reaction. So what is happening? The reaction of calcium oxide to convert into lime water, or the conversion of quicklime into lime water, is nothing but an exothermic reaction. Bestest example if I have to say. So the exothermic reaction, when you touch this, immediately it will become very, very hot. Same simple example, one more. When you take zinc, when you are dropping into a beaker containing HCl as sulfuric acid, hydrogen gas is evolved, I said, there also the beaker becomes very, very hot. So here the concept is the release of energy, release of heat. That's why such reactions are called exothermic reactions. So the beaker becomes, what will happen to this beaker? The beaker becomes, I said, it will become hot. See here, I have written that heat in the presence of, in the form of delta. So exothermic reaction is this. Suppose if I have to take the endothermic, so hope that because of the place I have written in this way, I'm putting it in a box, so you can take it, lime water. I'm sorry, just I have written, you should not write like that, you need to write straight. Shall I write it straight, students? Okay, that is better for you, not to confuse you all. I'll write the reaction straight like this. Calcium oxide plus water gives me calcium hydroxide. So this is quicklime, this is water, this is lime water. Okay, so what plus delta? Delta means exothermic reaction. Done. Here in this case, when I have to speak about endothermic reaction, simple, you're going to take barium hydroxide. Okay, and you're going to add to this ammonium chloride. So don't worry, remember how to remember reactions. I'll be teaching you how to remember the reactions, but as of now in the first chapter, learn what are precipitates, what are evolution of gases where there is change in temperature, right? So here in endothermic reaction, I'm going to take barium hydroxide and ammonium chloride, right? So here what is happening? Barium chloride and ammonium hydroxide combine together and forms a compound ammonium hydroxide and barium chloride. Now when you touch this beaker, immediately the beaker containing these two, it will be very, very cold. It will absorb the heat. Means where should I write the delta? Here delta I wrote it outside after the product. Here delta I'll be writing it inside. See, this is to the heat is outside towards the product. Here the heat is inside towards the reactants. So the reaction is, or the beaker is, it will become very, very cold. So you can touch that, very nice cold this one. So it shows that when you are writing the heat content inside towards the reactants, it is an endothermic reaction. When you write the heat content outside the reaction, it is an exothermic reaction. So in this case, the reactant or the reaction or the change in temperature, it becomes hot. Let us write not heat, let us write hot. And in this case, the reaction, the reactants or the beaker becomes cold. So this is a change in temperature, either exothermic or endothermic in nature. Now, the next, change in state, that is one more characteristic. Let us write that. So let us erase everything. I think you have noted this. Okay, so this thing I'll erase. The last characteristic of a chemical reaction is nothing but change in state. Okay, let us erase this temperature and put it as change in state. Simple example. So here you're going to take a wax candle. So changing, what is meant by a state? State is nothing but solids getting converted to liquids, liquids getting converted to gaseous, gaseous getting converted to plasma, plasma getting converted to BEC, right? There is also conversion of solid directly to gas also. Simple example, as I said, I'm going to take a wax candle. So what is a wax candle physical state? Wax candle is now solid. So yes, S stands for solid. When it starts burning from solid, slowly the wax starts melting. It will go to a melting stage, that is nothing but liquid. After some time, it starts giving out water droplets. Okay, water droplets, and finally you will be seeing there is a formation of vapor on the surface of the candle. You'll be seeing the vapors form, the fumes form. So the vapor is nothing but the gaseous state. So isn't it change of state? From solid it has converted to liquid, from liquid it has converted to gaseous or the vapor phase. So these are the different characteristics of a chemical reaction. Let us summarize once. Characteristic, or till now I have learned the definition of chemical reaction. I have learnt the examples of chemical reaction. I have also learnt the characteristic with examples. Very detailed explanation. Please just say, students, nobody will give you like, I have taken two examples for each. So change of state, change of color, change of or evolution of light, heat, gas, and I've also say same formation of precipitates also. So thank you for watching. This is I expect you all to watch the video and note it in your WOC book. I'll meet you again with the next important thing, that is balancing of chemical equations.